Good day everyone. In this module, we will be explaining how we can compute for the rate of convection heat transfer from the surface of a flat plate, cylinder, or sphere when there is a fluid forced to flow over it. At the end of this module, it is expected that you should be able to explain the main computational challenge in analyzing convection heat transfer to or from surfaces, explain the difference between local and average Nusselt number, and assess the best correlation to use in solving the Nusselt number for a convection heat transfer problem involving external fluid flows based on the type of geometry and prevailing flow regime. So let's start our discussion with what makes convection heat transfer analysis more complicated than the other two modes of heat transfer. The main challenge that we need to grapple with in convection heat transfer analysis is how to find the value of the convection heat transfer coefficient. We have already established that the convection heat transfer coefficient is directly related to the Nusselt number. But determining the value of the Nusselt number is not that straightforward since its value is strongly influenced by two major factors: the type of fluid flow and the convection heat transfer process type. Now, the type of fluid flow is dependent on three major factors. First is the kind of fluid and its corresponding thermal properties. Second is whether the fluid is flowing over the surface of an object or within a fluid conduit. And third is how turbulent the fluid flow is. On the other hand, when we talk about the type of convection heat transfer processes, we are concerned about whether there is forced or free convection at the surface or whether a fluid boils or condenses at the surface. Therefore, determining the Nusselt number is largely dependent on the combination of conditions that is present in the fluid flow. This diagram shows what makes convection heat transfer analysis more challenging than conduction and radiation. Since for each combination, there is a specific empirical formula dedicated to solving the Nusselt number. When we refer to external force convection, we refer to the heat transfer occurring due to the flow of fluid over flat plates or over curved surfaces such as cylinders or spheres. And as we have previously mentioned, convection heat transfer over these surfaces is largely affected by how turbulent the flow is. In the next video, we will discuss how to characterize the convection heat transfer due to fluid flow over flat surfaces.